Assalamualaikum warahmatullahi wabarakatuh. This is our presentation on our FYP, which is a review paper on phytochemical compound as a potential inhibitor for SARS-CoV-2. And this presentation is brought to you by Ahmad Yusri bin Yusof, which is me, Muhammad Hakimi bin Jamil, Nur Alia Natasha binti Ramli, Nur Shahira Amila binti Roslan. On the introduction, I will tell you a little bit about what actually are we doing on our FYP. COVID-19, or Severe Acute Respiratory Syndrome Coronavirus 2, is found in 2019, and it is a virus that caused millions of people's life, including Malaysians' life. The way the virus works is actually it latches itself on humans' respiratory system, causing inflammation, hard of breathing, and other infections that could cause humans' life. On our FYP, we reviewed several of scholars' articles on how a natural compound could inhibit this virus, thus preventing its effects on humans. We specified the natural compound into four, which is artemisinin, curcumin, gallic acid, and androglypholide. And the way the compound will affect the virus will later be explained in the video. All of the paper reviewed are studies based in silico and molecular docking. In a simple way, molecular docking is a virtual way to predict inhibition of a protein with another compound. The objective of our FYP is to explore the supporting studies of artemisinin, gallic acid, curcumin, and androglypholide as a potential inhibitor for SARS-CoV-2.
Assalamualaikum. My name is Muhammad Hakimi bin Jamil. I am going to talk about finding in artemisinin. Artemisinin, or in a Chinese name, Qinghao Su, is an antimalarial drug that was discovered in China in the early 1970s. Artemisinin is isolated from Artemisia annua, a sweet wormwood herb used in traditional Chinese medicine. Artemisia annua is a common herb found in many parts of the world and has been used by Chinese herbalists for malaria treatment for more than 2,000 years. For the treatment of malaria, organic extracts of Artemisia annua have been found to be more effective, quicker, and less toxic than chloroquine and hydrochloroquine. So, as for the main topic, I've made a research about artemisinin as a potential inhibitor for SARS-CoV-2, or better known as COVID-19. So, for the first article, SARS-CoV-2 target that has been chosen is S-protein RBDH-ACE2 complex. As for the control, artemisinic acid, artesunate, artemisone, artemiside, artemisol, and artemethyl has been chosen. For the effect, analysis of molecular docking results show that the hydroxyl group of hydrochloroquine molecule forms strong hydrogen bonding with ASN 501 side chain residing on one part of the receptor binding motif of the S protein. Data analyzed show that artemisinin and its derivative compound has produced the lowest and closest VINA score, that is negative 6.0 kilocalorie, that better than hydrochloroquine. As for the next article, SARS-CoV-2 target that has been chosen is 6LU7. For the control, quercetin, hispurylin, curcuma, and circimaritin has been chosen. Binding energies derived from the molecular docking of the SARS-CoV-2 main protease 6LU7 active site were presented in this paper. As for the effects, binding energies derived from the molecular docking of the SARS-CoV-2 main protease 6LU7 active site were presented in this paper. Artemisinin demonstrates low binding energy relative to hydrochloroquine at the 6LU7 active site. Hydrogen bonding was predicted between HIS-163 and GLU-166, and the hydroxy functional group of 6LU7 active site. As for the third article, SARS-CoV-2 target that has been chosen is 3CL-Pro. For the effect, compared to chloroquine and hydrochloroquine, that is antimalarial molecule, artemisinin had provided the highest docking score, that is negative 6.40 kilocalorie per mole. Importantly, against human hepatitis B and C virus, diarrhea virus, and etc., artemisinin has shown broad antiviral activity.
Assalamualaikum. My name is Nur Shahira Amila binti Roslan. So now I will explain about gallic acid. Gallic acid, which is also known as 3,4,5 trihydrobenzoic acid, is a polyphenol compound and has gradually won a considerable amount of attention because of it is ubiquitous in fruits, vegetables, and herbal medicines such as grapes, gallnuts, pomegranates, and tea leaves. Gallic acid can be found in nearly every part of the plant such as bark, wood, leaf, fruit, root, and seed. Gallic acid can be used for a lot of things. For example, as antioxidant, antimicrobial, anti-cancer, anti-inflammatory, gastroprotective, cardioprotective, neuroprotective, and metabolic disease prevention activities. As everyone knows, COVID-19 is one of the virus that is spreading all over the world now, and its cure hasn't ever been found yet. And a study on gallic acid as a potential inhibitor for COVID-19 has been done throughout the year. So the result for the first journal showed that study of gallic acid on target protein, which is spike protein, showed that gallic acid is one of the potential inhibitor for COVID-19 because the LF score that we need is between negative 5.75 to negative 11.03, and the result that we got for gallic acid is negative 6.91. For the second journal, it agreed with the first journal, which is gallic acid is a great potential for to cure COVID-19 because tracking analysis result arrived by binding energy value show that gallic acid is in the second rank, which is after the densifer that is used for the control. But not every journal agreed that gallic acid is a great potential to cure COVID-19, as in the third journal, gallic acid showed that it is non-compatible enough as it lacks in free factors, so it is rejected as the potential to cure COVID-19.
Curcumin are phytochemicals found in turmeric, also known as curcuma longa, and are well used in the world as spices in cooking and some cases in traditional medicine. It is known to have antioxidant, anti-inflammatory, anti-cancer, and antiviral effects. Curcumin also shows or exhibit activities against viruses that had fatally affected humans before, such as HIV, dengue virus, HSV, hepatitis virus, influenza A virus, and Ebola virus. We'll be looking at some of the reviewed paper on curcumin towards the virus. First off, the articles is about virtual screening of curcumin and its analogs against the spike surface glycoprotein of the SARS-CoV2 and SARS-CoV. Now the article views on the capability of curcumin compound in inhibiting the spike protein of SARS-CoV2 to prevent the viral effects. The overall articles talks about the binding energies of the compound towards the target protein of the COVID virus, in which case the target protein is the S protein. Now, the article talks about the capability of curcumin in inhibiting the virus COVID by testing its energy binding towards the compound, and it shows positive results. Now, it also specified the curcumin's derivative in which one is the best to inhibit the virus protein, and it is specified which is bis-dimethoxycurcumin, compound 4, and compound 2. The second article reviewed is titled Curcumin to inhibit binding of spike glycoprotein to ACE2 receptors. Now, the second article differed from other article is because the aim is not to only bind the curcumin compound with the spike glycoprotein but also to prevent the replication of the SARS-CoV-2 virus itself with curcumin keto and eno form. Now, The type of form is actually another type of derivative of curcumin. And why the form is chosen, it is because it creates strong hydrogen bond with angiotensin converting enzyme 2, which is the ACE2, that is synthesized by the virus for the host cellular entry. And it shows the result that keto form is more favorable as for its docking scores, binding energy, and molecular dynamics simulation. The third article reviewed is entitled Understanding the Role of Natural Medical Compound. Now, the third article dives into how natural medical compound has a role in battling against SARS-CoV-2 virus through in silico studies. As you all know, there are a lot of medical compound out there. So the article specified into two medical natural compound, which is curcumin and allicin. Now, again, in this article, it focuses more into its derivative, which is on the curcumin, hexahydrocurcumin and hexahydrocurcuminol, and on the allicin, it is allicin and ajoene. The derivative proven to be good binding compound through promising result and the molecular docking.
Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Noalia Natasha binti Ramli. So I will present about my findings, which is andrographolite. Andrographis paniculata can be found in Malaysia, and it is known to have a major bioactive chemical that have potential over many investigations. The compound in this plant known as andrographolite. It can cure many diseases such as sore throat, flu, upper respiratory tract infections, dengue, and HIV. Research has made andrographolite can inhibit SARS-CoV2 by binding interface of S-protein human ACE2 complex. There is no specific treatment, but we can just inhibit this virus by using the phytochemical compounds in this plant. I have made some research on various articles, and I have choose several articles because I want to explain more about this study. Okay, this is the first article. As you can see from the results, andrographolite has shown to have a higher binding affinity with 6LU7. Andrographolite is successfully docked against main protease of SARS-CoV-2 using in silico computational docking tools when compared to synthetic compounds such as disulfiram, tideclusib, and chiconine. Andrographolite also showed great binding affinity towards drugs such as lopinavir, oseltamivir, and ritonavir. Other plant molecules that are studied to inhibit SARS-CoV-2 are failed to prove their binding score compared to andrographolite. So this is the second articles. Based on the results, andrographolite shown to have a higher binding affinity than remdesivir towards aspartame, same binding affinity with remdesivir towards 3CL-Pro, lower binding affinity than remdesivir towards PL-Pro, better binding affinity than remdesivir towards RDRP. Even andrographolite has lower binding affinity towards PL-Pro. They also have inhibitory effects on the activity of PL-Pro. Remdesivir used as a positive control. Remdesivir shown to have good interaction with RDRP protein and have a good binding affinity towards 3CL-Pro, S-protein, and PL-Pro. For the last article, hydroxychloroquine used as a positive control to compare the interaction because this compound has reported it can bind between the interface of these two proteins, S-protein, human ACE2 complex. Andrographolite fits perfectly between the interface of S-protein, human ACE2 complex. We want to find drugs that can inhibit particular region and have lesser side effects than hydroxychloroquine. From the results, andrographolite shown to have a higher binding affinity than hydroxychloroquine against ACE2. Coronavirus disease, COVID-19, occurs recently and shows many symptoms such as fever, fatigue, shortness of breath, sore throat, and headache. Researchers still haven't found a vaccine for this virus. Even there are many potential vaccines are in development, there is no guarantee that it will work. We have made some research of chosen phytochemicals as a potential inhibitor towards SARS-CoV-2 using in silico methods such as andrographolite, gallic acid, curcumin, and artemisinin. In conclusion, findings from this study show that these compounds have their effectiveness with binding score towards SARS-CoV-2 main protease.